Welcome to the seminar series on sewer and pipeline engineering. My name is Bert Bosseler. I am the Scientific Director of the IKT Institute for Underground Infrastructure. In this seminar session we will be looking at the rehabilitation of sewers and pipelines, and this time it's about renovation. And we want to proceed in 3 steps. First, we want to ask how the term renovation is defined in sewer and pipeline engineering. Then we want to get to know and distinguish between the individual groups of methods and techniques. And then we will look at some typical technical examples for each group of methods. But let's start with the terminology. When do we speak of renovation, and what do the standards and regulations say? If we look at the international standard ISO 24516, it refers to the definition of the European standard EN 16323. And there it says, for the term renovation, work incorporating all or part of the original fabric of the drain or sewer by means of which its current performance is improved. So on the one hand, it is about improving the performance of the system, and on the other hand, the original fabric of the system is to be incorporated. That means it is to remain in use. From a financial point of view, this is of course a very interesting option. Improving sounds like investing, and so refinancing the costs over the entire future useful life. And including the original fabric means that we do not give up the existing asset, but continue to use it. In this way, we avoid special commercial depreciation. So we see that some seemingly technical definitions can also have considerable financial motives. But which methods can we use for renovation? What groups of methods are there? Here we see a listing from EN 15885. Renovation is divided into 8 essential subgroups here. Finally, there is a general reference to other groups of renovation methods that are not classified in the standard. All method descriptions start with the term lining. So the sewer is to be improved over its entire length. In rehabilitation practice, however, other terms are also used for the methods. On this slide we see the definitions according to the European standard on the left. Next to this we now see the terms as they are commonly used. The methods are summarized in 3 groups. This grouping is not found in the standard, but it is very helpful for understanding the quality influences. And let me explain this. In all lining processes, new pipes are installed over the entire length of the old pipe. How these new pipes are produced, however, varies greatly. In the first group, we find methods where both the material of the new pipe and the shape of the new pipe are already created in the factory. This means that complete new pipes are delivered to the construction site and are inserted into the old pipe there. In the second group, the pipe material is already produced in the factory, but the geometry, so the shape of the pipe, is first created on the construction site. In the third group, both the pipe material and the pipe shape are only created on the construction site. This can be a coating or a pipe liner that is cured only after it has been inserted into the old pipe. So there are big differences between the processes. And now we take a look at the technical examples in detail. Let's start with the first group. Material and pipe shape both are already produced in the factory, and the finished pipe is transported to the construction site and installed there. So what does that look like? Here we see 2 methods illustrated, both known as slip lining. The first is lining with discrete pipes. That means individual pipes are delivered to the construction site and inserted into the pipeline. The pipes usually have pipe joints similar to those we already know from pipe jacking. That means no large sockets that take up too much space. Once all the pipes have been inserted, the annular space between the new and the old pipe is usually filled with a grout material. There are 2 reasons for this. Firstly, the position of the pipe string in the longitudinal direction is secured so that the pipe does not move with temperature changes and, for example, tear off from the lateral connection pipes. On the other hand, the pipe must also be well bedded so that it does not buckle under external water pressure, for example. Below, we see the lining with continuous pipes. Here, the pipes are also pre-produced in the factory and then delivered to the construction site. The pipe joint is made on site by welding. Of course, this is only possible with weldable materials such as polyethylene. The welding process takes place on the surface, so a relatively large excavation pit is needed to pull the pipe string into the old pipe. The annular space between the old and the new pipe is also usually grouted. With both methods, we have the advantage that the pipes have already been checked for quality in the factory, and usually only flawless pipes are delivered to the construction site. The big disadvantage is the low adaptability of the pipe string to the geometry of the old pipe. There is always a considerable loss of cross-section because the new pipe has to be much smaller than the old pipe so that it can be inserted. Now we come to the second group of methods. This group includes the close-fit, spiral wound and segmental lining. Here too the pipe material is produced in the factory. However, the pipe geometry is only created on site. So what does this look like? Here we see the close-fit slip lining method. There are two options. In the first case, the pipe string is delivered on a drum. The pipe cross-section is folded into a U shape. The cross-section and also the moment of inertia are therefore much smaller than with a circular shape. The pipe can therefore be bent more easily and pulled into the old pipe with little space required. After being drawn in, the pipe is then formed back into the circular shape, usually by means of warm water or steam. The manufacturers often speak of a so-called memory effect. According to this, the pipe should prefer its round shape of production when it is formed back. Below we see the second method of the close-fit process. Here the pipe is drawn through rollers under the influence of temperature, and in this way the cross-section is reduced. After being pulled into the old pipe, the pipe is relieved again and expands to the original dimension. Another technique in which the material is produced in the factory and then assembled into a pipe at the construction site is the lining with spirally wound pipes. At the construction site, the plastic strip, which was pre-produced in the factory, is let down from a drum into the manhole. A new pipe is then wound from this strip, and it slowly advances from the manhole into the old pipe. The pipe joint runs in a spiral along the entire length of the pipe. The annular space is usually filled with grout. The spirally wound pipe method is also available in other variants. For example, with some methods, the pipe can be subsequently expanded until it is close fit to the old pipe. In another variant, the pipe winding machine itself moves through the old pipe. The strip is added behind it so that the new pipe does not have to be pushed through the old pipe. Here too it is possible to work with a small annular space. In addition, other cross-sectional shapes can also be rehabilitated, such as egg-shaped or rectangular sections. To increase the stiffness of the pipe, a metal reinforcement can also be included into the wall profile. Here we see another possibility for bringing prefabricated elements into pipe form only on the construction site: the segmental lining method, or lining with pipe segments. In this process, pipe segments are mounted in the sewer in such a way that a new pipeline is created. This new structure is then firmly connected to the old sewer. The decisive factor for classification as a renovation method is that it is applied over the entire length of the sewer or pipeline. A partial lining in the invert or in the crown is also classified as renovation if the entire length between two manholes is improved in the process. As a rule, partial linings in the invert or crown serve to protect against corrosion. In the invert, the hydraulics can also be improved. The connections between the elements are extremely important in segmental lining. These must be permanently tight and corrosion-proof. The annular space between the lining elements and the old pipe is usually filled with grout. Now we come to the third group of methods. Here, individual material components are delivered to the construction site and then processed into the actual pipe material on site. The final pipe shape is also created at the construction site. This group includes CIPP lining, coating and grouted-in-place lining. So let's take a look at this in detail. Here we see a schematic illustration of the CIPP lining process. A soft hose is delivered to the construction site, inserted into the old pipe and then cured on site to form a new pipe. CIPP liners consist of a so-called carrier material that is impregnated with synthetic resin. Under the application of energy, for example UV light or heat, the synthetic resin can cure on site. Depending on the curing method, the hose is cooled during transport or protected against UV radiation. This keeps it soft and flexible for installation. GRP or needle felt is used as the carrier material, and unsaturated polyester resins, vinyl ester resins or epoxy resins are usually used as the resins. In this picture we see a process variant called inversion process. Here the hose is inverted into the old pipe by means of water pressure. The liner material is fed inside the liner and the water is refilled as necessary. The water pressure presses the liner against the pipe wall and turns it inside out. The special advantage is then the new pipe can adapt exactly to the old pipe geometry. With this variant, the resin is cured by pouring warm water into the pipe string at the end of the inversion. In another variant, the liner is simply pulled into the old pipe and then set up using air pressure. This is also referred to as the pulling in method. Curing is then usually carried out using UV lamps that are pulled through the liner. Depending on the type of process, the carrier materials also differ. In the inversion process, needle felt liners are usually used. Since there is no friction, large diameters and long distances can be rehabilitated. In the pull-in method, glass fiber mats are usually used as the carrier material. On-site quality assurance naturally plays a special role in the liner process because both the pipe material and the pipe geometry are created on site. This means that the pipe is always thoroughly inspected with the camera after installation and, as a rule, pipe samples are also taken to test the material properties in the laboratory. In most cases, these samples can be taken in the manhole area without damaging the actual rehabilitation result. Another method in which the material is only created on the construction site is the coating method, also known in the standards as lining with sprayed, troweled or cast-in-place material. These methods are used for pipes, manholes and other special structures. In the case of pipes, the coating usually serves solely to protect against corrosion. Manholes are also to be sealed with coatings. Here we see some picture examples from manhole renovation. On the top left, a plastic is sprayed on by hand. On the top right, it is applied with an automatic spraying device. Below left, we see an automatic spraying device for mortar, but mortar can also be applied by hand. We see that in the bottom right of the picture. For mortars, the material is first mixed with water on site. With all coatings, care must be taken to ensure good surface preparation. The bond strength between old and new material depends largely on the strength of the old material and how well the new material interlocks with the substrate. Before coating, the old sewer wall must therefore always be removed down to the load-bearing substrate. Well, let's move on now to a method that involves a combination of a plastic sheath and injection grout. In the standards, we are also talking about the so-called lining with a rigidly anchored plastic's inner layer. On the inside, there is a plastic sheath made of PE or PVC. This sheet has studs on the back, which can serve both as a spacer and as a rear anchoring. Similar to lining with continuous pipes, the annular space between the plastic sheath and the old pipe is grouted with mortar. The main difference, however, is that the plastic sheath alone that means without the mortar, would not be load-bearing at all. Only the cured outer mortar ring provides the load-bearing capacity. The plastic sheath seals the whole thing and also protects the mortar from aggressive fluids in the pipe. With regard to the use of mortar, we distinguish between two cases. In the first case, here on the left, the mortar can also penetrate cracks in the pipe or even cavities in the bedding. Thereby, the mortar also stabilizes the old pipe and the bedding. However, there is then a danger that the mortar will run away into cavities in an uncontrolled manner and seeks its own way in the underground. For this reason, there is also a second option, shown here on the right. Here, a pre-liner is first blown in to separate the old pipe from the new pipe. This pre-liner prevents material from flowing into cracks or external cavities. However, in consequence, this method does not improve the old pipe soil system. With both methods, the quality of the mortar is of particular interest in terms of quality assurance. This also includes the homogeneity of the mixture. After all, the mortar has to be injected over long distances through a very small annular space, and it must also distribute evenly between the plastic studs. I think these examples have made it clear what renovation is all about and what differences we can recognize with regard to quality assurance. Let me summarize this briefly. We can already find a basic classification in EN 15885. All methods are called lining, so they should lead to an improvement over the entire length of the sewer section. The methods can then be divided into three groups. The first group includes lining with discrete and with continuous pipes. In both cases, the pipes are completely pre-produced in the factory. This applies to both the material and the final pipe shape. The pipe quality can also be checked in the factory so that, as a rule, only flawless pipes are delivered to the construction site. However, the adaptability to local conditions is then also very low. The second group includes the close fit, the spiral wound, and the segmental lining method. Here, too, the pipe material is produced in the factory. However, the actual pipe shape is only created on site by reshaping the cross-section, or by winding a plastic strip, or by assembling individual segments. The third group includes CIPP lining, coating, and the grouted-in-place lining. Here, individual material components are delivered to the construction site, processed on-site, and only cured in the sewer itself to form a pipe with the desired geometry. Essential steps of the production process therefore take place within the old sewer. Of course, this is a special challenge for quality assurance. Do we get 100% quality, or are there also failures in production on site? Sampling and testing are of particular importance here. If the quality assurance is successful, then the on-site processes have a significant advantage. The space at the surface required when introducing the materials into the sewer is usually small, and the new pipe can adapt directly to the old pipe geometry. The difference in adaptability is also illustrated in this picture. We can see two pipes that were rehabilitated with renovation methods. On the left with CIPP lining and on the right with close fit lining. The CIPP liner could be completely adapted to the old pipe geometry. No annular space is visible after installation. The close fit liner also fits tightly, but its adaptability is not quite as great. We can still see a small gap at the top right. Finally, let's take a quick look at an example of the last class of renovation methods. EN 15885 states that there can, of course, also be other procedures that cannot be classified in the general lining classes, but are still called renovation. One example is Masonry Renovation according to the Düsseldorf system. After all, renovation means that we continue to use the old fabric and bring about an improvement over the entire length. This is exactly what happens in this case. The exact procedure is shown here in individual steps. After cleaning and preparation, the joints between the bricks are gouged. Broken bricks are replaced and the brickwork is repointed. If there are cracks in the masonry, they are grouted. If necessary, the pipe invert is lined to provide better protection against corrosion and the laterals are reconnected. In the following picture, I would like to show you some more impressions of this process. Here we see how the joints between the clinker bricks are cleared out to such an extent that only intact joint material remains. In this picture we see the repointing with mortar. On the right we see the mortar pump. Here we see the finished work. All joints look like new again, defective clinker bricks were replaced. The quality of the joint renovation can be checked by taking a drill core. Here we can clearly see the difference in color between the old, still intact joint material and the new joint material. Both combine to form a completely intact joint again. Cracks in masonry are usually closed by crack ejection. This applies in particular to statically relevant longitudinal cracks. Here we see crack injection at the crown. This is carried out after the joint repair. Through the grout packers, a mineral cement suspension is injected next to the crack until the material completely fills the crack. Here are two more pictures of the completion of the rehabilitation. Finally, the laterals are properly connected and the invert is lined with ceramic tiles. And this brings me to the conclusion of this session. We have seen that the concept of renovation is based on an improvement of the old sewer. That means the sewer is improved over its entire length and its useful life can be significantly extended. The old fabric continues to be used in the process. All method groups have a lining character and are therefore also referred to as lining methods. The technical examples have shown that there are great differences between the methods, depending on whether the material and form are created in the factory or on the construction site. Quality assurance on the construction site is therefore a particularly important issue in many renovation processes. Thank you.